Hi, I'm Alexis Richardson. This is my colleague, Stefan Prodan, from Weaveworks. We're going to talk about Flux. This is our special CNCF allocated slot for every CNCF project, sandbox or otherwise. There's a couple of slots to talk about the project. This is supposed to be an introductory session. So if you have heard all of this before, I apologize. Stefan is doing a deep dive later on this week. Tomorrow. For people who want to get really hands-on. I'm going to introduce him and talk a little bit about the history of the project and some interesting news, which is shown at the top here. Let's get that out of the way first. Who here has heard of Argo CD? And who here has heard of Flux? Right. The answer from now on should be the same because these projects are merging into one, which is something that happens very rarely in open source, that you take two successful projects which have thousands of users and bring them together into a single thing. It's like a sort of planetary conjunction. We should expect unusual things to be happening that we see in the fields. But it's great because what's happened here is it's an example of parallel evolution. I don't know if you know the story of the octopus eye, but the octopus eye is very similar to the human eye. It's a ball. It works by light coming in and getting reflected into the back of the eye where it gets processed. And this is something that was created through evolution. And it's remarkable how similar the physical properties of the eye designs are, yet they've grown in two completely different environmental niches, fulfilling apparently similar needs, hence the similar design. Weaveworks started our business wanting to help developers create applications using containers. We thought this would be a big deal about 5 years ago. When we founded the company, it was in a week of something called Kubernetes being founded. I, being a skeptical person, thought that Kubernetes would never take off because it had a very silly name. Luckily, I was wrong. It wasn't long before we were building a SaaS product as part of our marketing strategy to reach out to developers and help them build these applications. And as a SaaS product, we had to run it on something. And we wrote our own scheduler first, kept blowing up, and we ended up spending more time writing the scheduler than we were writing the app that people were supposed to be using and buying. And so somebody said, well, let's get an off-the-shelf one. And we looked at Mesosphere, and nobody could understand that. We looked at Docker, and we tried to put patches into Docker Swarm, but they were pushed back by the Docker team. We talked to HashiCorp about Nomad, and they said, don't use Nomad. That was version 0.2. So by process of elimination, we found Kubernetes, which meant that we had to become people who run Kubernetes. Now, I don't know if you are in the audience, if you have people who run Kubernetes, but it's not easy to do. You have to do a lot of stuff. Like, you have to figure out how to monitor it, how to deploy it, how to put apps onto it, how to monitor those apps, and if things blow up, how to get it back up again. And being a business person, I kind of ignored all of this complexity until one day I was sitting in the office and it was sunny outside and there were birds tweeting, and somebody said, voice across the room said, if I press this button, I will probably wipe out all of our clusters in production. At which point we go into the sort of slow motion, I'm standing up, saying, no, like in the Matrix, and then I hear click, followed by an English swear word, and then all the clusters are blown up. And the team go into disaster mode and bring everything back up again in about 40 minutes. Everything, including dashboards, apps, clusters, connections to databases, different zones, different stages. And afterwards I thought, well, that was pretty quick. Not bad, 40 minutes, 45 minutes. Now we're doing this in just a few minutes because we got better at it. But I asked them, what did you do to make that possible? And they said, we can build a correct cluster for an entire application at will because we have a complete description of everything we're running stored in Git. And we can use that to instruct the system how to build itself. I'm like, oh, that sounds really clever. So we started calling this GitOps because it was operations driven by a description in Git. And in GitOps, one of the things that you do is you deploy apps to clusters, not by sitting outside running kube control or a bunch of scripts or Jenkins, or Spinnaker, or other things that sit outside the cluster. Instead, you give the cluster a set of instructions, and it runs agents inside itself that go, aha, my cluster is in the wrong state. I need to update myself, and it updates itself. And so that is how we deploy apps and clusters at Weaveworks. We let Kubernetes do all of the management of deployment of apps and services and clusters, which of course means there is a bootstrapping question, which we'll talk about another day. Now, I mentioned the octopus eye. Intuit wanted to have Kubernetes to power their incredibly large business, and they worked with a team from a company called Applatix, a great team that they ended up acquiring Applatix. And they said, please build us a Kubernetes-based infrastructure for everything. So off they went. And they too had to install clusters, install apps, manage apps, change apps, same as us. And they came up with the same bloody design. So now we have two projects doing the same thing independently. So we thought this is a silly situation, because this is open source. We're supposed to collaborate. We collaborate. And since we're not trying to do things like hold features back from you to force you to buy enterprise Flux, it's all out there. Everything that you can see, what you see is what you get. We have other products for enterprise stuff like policy and governance. We've had a strong incentive to team up with Intuit. It took a while to convince each other that we could work together, but I'm really happy to say, thanks mainly to the actual engineers who do the actual work, not to people like me, the teams agreed to work together and started to collaborate and now have built the first step of this, which is what we call GitOps engine, which will become the back end of a new Argo Flux. And there'll be Argo Flagger, which is a Stefan thing that does progressive delivery, and Argo workflows, Argo UIs, Argo events, and everybody will have one beautiful tool chain for doing deployment, application delivery, and all these other good things, which I think is a wonderful thing. And I think the engineers who did that deserve a round of applause, please. Okay, so it mentions here AWS are also to be thanked for this. I hope there'll be other large companies soon, maybe. Stefan is going to tell you a bit about Flux in an introductory manner. Yeah. Is that good? Do you want to take over?
Yeah.
Shall I go?
Taking over.
Can I take my water? Okay. Thank you very much. Over to you, Stefan.
Okay, so this is my favorite slide on GitOps that I think it's very simple to explain what Flux does, because Flux is a simple tool. Flux is not a complex tool. It doesn't try to do many things. What it tries to do is replace all this CLI tooling with another CLI, much known than any other CLIs out there, which is Git, right? So instead of changing the state of your cluster with different tools, with kubectl, with Helm, with Kustomize, and yeah, maybe some scripts that wrap those CLIs, we want to replace all of that with a single command, which is git push. You modify something, you push it to your Git repository, and from there, that something ends up on the cluster. And it can be anything. Flux is not opinionated. Flux doesn't look at what have you put in your Git repo that defines the cluster. It can be a custom resource definition. It can be a namespace. It can be a role. It can be anything that Kubernetes itself supports. And Flux doesn't do a validation of what's there. Of course, when it applies it, if it doesn't work, then it will tell you. So it works great with OPA and other projects in the space. And why we should use this kind of approach to infrastructure. One of many advantages is the fact that if you use Git, you have this nice history of any change that happened on your cluster. So you can do Git history and you can see who did what on the production cluster. You can engage your team in approving changes. Like if we are running all kinds of CLIs and everybody is doing it from its own computer, then we have no idea what exactly changed in the cluster. So basically, we need to I don't know, have a very solid logging solution around Kubernetes, subscribe to all the events, and it's very hard to reproduce the state. Like if you lose a cluster, how can you reproduce everything that was there? Of course, there are tools like Valero and others that can snapshot etcd, you can restore that state somehow. We think GitOps solves this problem easily because if you lose the cluster, your state is stored outside, it's in a Git repo, you create a new cluster, you connect a new Flux instance to that cluster, and you point it to the old repo, and it will just restore everything that was there. Now, of course, this everything doesn't mean stateful sets. Doesn't mean you can restore hard drives, right, or databases or stuff like that. You can restore everything that was before in the Kubernetes etcd storage. And even that is not true, because what you store in Git is an intention. For example, with Cert Manager, I want a certificate, so you store the request of a certificate in your Git repository. That Git repository doesn't have the actual certificate. Cert Manager will talk to Let's Encrypt and will get that object for me and creates it on the cluster. So desired state, what we save in a Git repository, is not the actual state, is an intent. I want, if something breaks, I want to get to that thing, but it's not like a database snapshot, right? So for Let's Encrypt, you destroy the cluster, you create a new cluster, you link to the same Git repo, and Let's Encrypt will do the request again. Cert Manager will do the request again. You'll have like similar certificate, but it's not that certificate, right? So when you are doing GitOps, you have to be aware that you cannot, that's not the whole state. It's something that you desire. And yeah, it has like things like you can easily revert to a previous version, everything that Git has. How can you do GitOps today? And this is like our definition of GitOps. Other GitOps tools maybe have other definitions. So it's an opinionated definition. Of course, you have to have a Git repository, a container registry, and here in the container registry part was very important is that you store there images that are immutable. That means no latest tag. Never push an image twice. If something changes in your code, if something changes in a config that you store inside the container, use a git SHA, use semver, use something unique when you push to that repository. That's something people usually forget when they do Kubernetes, that latest doesn't really work. So don't use it. And you need the continuous deployment process. This is more about how Flux works like. Argo has a different approach, and there is also Jenkins X and others. So Flux does pooling on the Git repository. It looks at it, and it has, by default, it has a 5 minutes interval. So you change something now, and in the next 5 minutes, it will apply that change on the cluster. And you can, of course, you can fine-tune that reconciliation loop. It also watches container registries. How it does that, it looks at your Kubernetes cluster, it looks at all the image pool secrets that you have there, it uses those secrets to connect to the container registry and creates a database, a cache of all the images that are running on your cluster and their tags. That is metadata. There aren't like, Flux doesn't actually download an image, but it knows if the image that I'm running now, it is the latest image or how many versions behind and so on. So it's only metadata. What other things a GitOps engine should do? Of course, it should have the possibility to undo changes that aren't going through Git. For example, let's say you have a deployment, you provision it in a GitOps way, then you go with kubecontrol and you do kubecontrol, edit that deployment, and you change something. Flux will undo it because we think, okay, you can react to Git hooks, like usually CI is built like that. You push something to Git, the system reacts to it. We think about continuous deployment inside the cluster should reconcile state all the time, even if there is no event, because you cannot know if someone modified your cluster, right? So Flux does this continuously sync, it continuously applies the desired state. So if you try to change it, it will undo your change, so you have to scale it to 0 if you want to do nasty stuff on your cluster. Puppet had the same way of running. Many other tools do this thing. GitOps is not a new concept, but it applies differently to Kubernetes because you don't need to store an intermediary state like in Terraform or in Puppet and all these other tools. You need this plan. This plan needs to be stored in another way, in another place. And when you apply the plan, you have to have a lock so you don't run it in parallel and so on. How Kubernetes is built, and because of etcd and the Kubernetes API, you don't have these constraints. You can apply a thing in parallel 10 times. It will just work. It will work once, and all the other actions are no-op. Another thing that Flux does, it verifies the identity of a committer with GPG. What that means, it protects you from, let's say, one of your team members got hacked, so someone has access to the master branch of your cluster repository, and they can do whatever there. They can change your cluster, deploy whatever they want. The signing key is not stored in GitHub, right? It's stored on your computer. So even if someone breaks your account, they don't have the key. They cannot sign that commit. And Flux sees the commit, but it will not apply it because it has a list of approved keys, of approved committers. It doesn't just look at the username of the committer. So this is how it has this security feature. This is how it looks. You put some YAMLs, any kind of YAMLs in a Git repository. Flux will pull those definitions from there, and it will use kubectl to apply it on the Kubernetes API. So it doesn't talk directly to the Kubernetes API. We shell out to kubecontrol. I'm going to use all the kubectl, kubelet, and yeah. Why we chose not to speak directly to the Kubernetes API when we do this apply is because of versioning, and we want to let you control your API version and how Flux applies it. And the best way we found it that you can replace that kubecontrol that comes with Flux and match that kubecontrol with your own Kubernetes version. So in this way, we don't have to have 5 Flux versions for all these, I don't know, breaking changes in Kubernetes and so on. It's on you. You can replace the tool that applies the change. Now, Flux talks a lot with the Kubernetes API to discover what's running on your cluster. So it uses informers and all this stuff, so it queries a lot the API. Why it does that? To enable garbage collection. We can detect that something was in a Git repository, it got applied on a server inside the cluster, then you delete that object from the Git repository, and we can reliably delete it from the cluster. Right? We don't delete other things, so if you do an apply, kubectl apply, we will not delete that object because we use checksums and we track all the objects that are in Flux responsibility. And the garbage collection stuff, it took like about 1 year to make it happen. A lot of people asked for it. We did it, but we had a couple of iterations how to implement this garbage collection thing in such a way that you don't put a lot of pressure on the API server. and you don't have to query each object, and we use the dynamic client Go for Kubernetes. This is how we discover everything that's running in your cluster. How you install Flux? It's quite easy. We have several ways of installing it. We have a fluxctl command line that has an install option and also has an identity option. And I want to show you how it works. We also have a Helm chart that has all the options out there to set up Flux in the read-only mode, to deploy it with PGP keys, to deploy it with your known hosts. For example, you can use a private Git repo. Flux doesn't know about it. It cannot connect to it, so you have to mount those kind of informations into Flux with the Helm chart. Then we also offer a customized base. So if you are, if you want to integrate Flux in, let's say, a cluster bootstrap, Kustomize is the way to do it. Don't bootstrap clusters with Helm, because Helm 3 will not support multiple namespaces and stuff like that. So these are all the offerings that we have for the installing. It's quite easy. I want to show you how it works. So I've cloned the get started repository from the Flux organization. And I have here a directory with namespace, the single namespace that I've put inside. It's nothing magic here, it's just YAML. And I have a workloads definition, and it has like a demo app, an horizontal pod autoscaler, and a service. And I can, so I have a cluster. Let's say it's nothing on the cluster. Okay, I will create the namespace. And I'm going to use this stuff. What it does, it sets my GitHub username, so Flux will be able to push changes back to the Git repository. So the default Flux install needs write access to your Git repository. So when we do that, to apply all these things. So Flux is composed of, I'm going to show you. So it's a Flux pod, and it's also a memcache pod. Why we need that memcache? We store there the container images metadata. This is why we use memcache. You can delete it, you can do whatever, is no problem. Flux will just refill the cache. It's not nothing actually stateful here. Okay, so I've applied those things, and now what Flux does when it starts, it looks up an SSH key in the cluster. So if you don't have an SSH key secret in the cluster with the Flux name, it will create one for you. So we can get the public key of that key with the identity command. So when I run identity, right. So it will get me the public key, and I can copy this public key, go to my Git repository, go to deploy keys, and I'll just add this deploy key with write access. And Flux is, until I did that, Flux every couple of 10 seconds or something like that will just check. Do I have write access to the repo? No. Okay, I'll try again. Now it has. And what will happen, Flux will create a Git tag when it synchronizes. But let's see if something is happening on on my cluster. I'll do get namespaces. I have a demo namespace in there. It's not there yet. Can do watch. Does watch work? Should work, right? Let's see what Flux does. I'm such a bad typist. Come on, man. So now, for example, now it scans images. It found memcache, and what it does, it looks up Docker Hub, and it gets all the tags and everything. I can force it to do a sync. I can do sync. Let's see if it works. It's not ready, so it tells me this one is not ready.
Did you have your user set? The name of the repo and Flux?
Yeah.
It says repo, it doesn't have your username. You didn't have your name.
Oh.
Yeah, so if you just install.
Yeah, I had to do that. I had to export my username, and I didn't do that.
Yeah.
Right. Where is it? Okay. Kind of hard to install Flux. Should work now, right?
Yeah. Your key should be the same too, so should be all good. You look at the bus logs.
I'll try the sync again.
Yeah.
Although I shouldn't have to do any kind of syncing. Let's see.
There you go.
Yay! I managed to install Flux for the first time. Right. So what happened now, I have this workload directory synchronized, and you can do a couple of things. When you install Flux, you can say synchronize those directories. Why we have this feature there is the fact that you can have a Git repository that you can manage multiple clusters. So you can have, let's say, a dev directory and a staging directory and production directory, and you can point different Flux instances to different directories. The idea of GitOps is very, very simple. You go here and do a change. I'm going to change the version. And in 5 minutes, it should do it. I'm not going to wait 5 minutes. I'm going to run this sync command. Why am I so bad at typing stuff? I had too much drinks last night. What's the command? KNS? This one?
Yeah. It's a kids forward NS. Dash kids dash FWD.
So it does that on its own on these 5 minutes, or you can tell it sync the change for me. This sync is blocking, but he can also do on the back end the same stuff. So you don't want to do that from a CI perspective, because this does a pour forward. So you need to open your cluster to your CI stuff. Yeah, we are working now on a way to expose a hook somehow secure that you can, and Flux will listen to that hook. I know Argo CD has that, so maybe in this Argo Flux collaboration, Argo Flux will get this kind of can be triggered via hooks. I'm gonna go back to the presentation. Do I still have time? Minutes. Okay, another thing that can do with Flux, you can create these update policies, and you can say, I have this deployment. I want Flux to monitor the registry, and based on these policies, I want Flux to update the actual deployment spec. And you can use regex, you can use glob, or you can use semver expressions to define how Flux should update your workloads. We also have customized support. How this works is you can have a customized layer thing inside your Git repository, and next to the main customization YAML, you'll have this file called Flux YAML, and Flux YAML is a way to tell Flux what kind of generators it can use. A generator can be anything that writes to standard out. So in this case, we run customize build for the whole repository. Customize build will write all the definitions to standard out, and from there, Flux takes that and applies it to the cluster. So you can mix and match different things here. For example, let's say you want to customize a Helm chart, and that Helm chart doesn't offer that kind of customization, right? You can do here, the first generator command could be Helm template, and afterwards, you can have a patch inside your Git repository and run a customized build for that. Other things you can do here, you can, I don't know, replace environment variables if this is the way you want to do templating, right? So we are not opinionated about how you are doing your own templating. As long as your tools will write standard out, Flux can call into them and use them. How you can add your own tools to the Flux image, you use an init container, and you can copy your binary into a shared volume so Flux can access it. We also have a multi-tenancy support for Flux. So the idea is that if you run a single Flux instance per cluster, that Flux instance has to synchronize everything. So it has to create role bindings, it has to create custom resource definition, all these global objects. And maybe you don't want to have a single Git repository with everything inside, all these dangerous objects that you can change, like network policies and everything, right? So the idea is you can have a system Flux that you deploy in a special namespace, and that Flux instance, the people in charge of that Flux instance are the cluster administrators. And that Flux instance can provision namespaces, and in those namespaces, it can deploy another Flux instance per team. So let's say you have 5 teams in your company, you gave each team its own Git repository, so they can do whatever they want in there, but they will not be able to affect another team namespace, because that Flux instance can only synchronize its state. You can put whatever in there, but it only works for that namespace. It's enforced with RBAC. So this is a way you can do multi-tenancy for your teams with Flux. You need multiple instances, right? And here is an example of what each team can do. We have secret support in Flux through the Binami seal secret operator. What the Binami seal secret does, it lets you store a seal secret, which is an encrypted file in your Git repository. It's a custom resource. Flux will synchronize it on the cluster, and the seal secret controller will decrypt it and will create a Kubernetes secret. So in this way, it's one way to store sensitive information in a public repository. No one can decrypt it. Everyone that has the public key can add new seal secrets to the repo. Another option, we have support for Git secret. It's a Git plugin that uses GPG encryption and so on. We have, and now we are working with Mozilla to add SOAPs support. It's a pull request open and is going to happen probably this month. There is also a project called Helm Operator. This is a sub-project of Flux. We love Helm and we want to be able to do Helm operations through Git, like you do with the normal Kubernetes deployments and services. So we created this Helm release custom resource that maps all the things that you can do from the command line, and it also has things like values. The Helm operator can do many things. I'll just speed it up. I'll give you an example here of how a Helm release looks like. You tell it where the repository is and what version, and it will install this chart. And you can also use automation, and you can provide values. So here I'm having a Helm release. Under the spec I have the values. So I set the image repository and tag, and Flux will update this custom resource. It will not rewrite your chart as itself. It will write this custom resource back to the Git repository, and it will, in this way, you can automate container image updates in your chart, in your charts. What Flux doesn't do right now, it doesn't automate the actual chart update. So if you create a new chart version and deploy that to your Helm repository, Flux will not be able to update it. And this is something that will come into the next versions. I'm not sure when. Do I have time? I'm off. Yeah, in Flux is not tiller. We get this question a lot, like, okay, Flux runs with cluster roles, so how is it not tiller? All operators act like tiller if they apply state on the cluster, right? We think that having good Git flows and protected branches and keys, it's basically the level 1 RBAC for your organization. This is how you can protect your clusters from unwanted changes. And of course, with the multi-tenancy model, even if someone tries to make a change that will impact the whole cluster, you cannot do it. And Flux works very well with Flagger, and you can use them together. They are not related in any ways. They don't know one of another, but you can build progressive delivery pipelines with both of them. The idea is that Flux synchronizes something from the Git repository, and Flagger detects, oh, there is a change, you want to deploy a new version, and runs a canary release for that version. And Flagger is the daemon that will write to Slack or write to Microsoft Teams, will give you notifications, it will give you Kubernetes events for this kind of changes. In order to see if Flux has some problems, you have to tail the logs or look at these custom events. Flagger has this integration with chat tools. And the roadmap, of course, we want to adopt the GitOps engine. We want to extract the container registry and image scanning as a sub-project. So for example, Argo can benefit from this thing that only Flux does. We want to have Helm registry scanning in there, and the biggest problem we have with GitOps tooling right now are the webhooks. So let's say if you want to deploy Istio or Linkerd or things like that, because Flux applies the whole state at the same time, you deploy the admission controller, the mutation admission controller, along with all your other applications. So there is a race condition there, and some pods will not get injected with the sidecar, for example, right? So you have to go there and delete those pods the first time you bootstrap the cluster to get the sidecar everywhere. So a way to solve this will be to add to Flux these readiness checks. So you can say, apply things in phases, apply first all these definitions, check for are they healthy, are they running, and only afterwards apply the whole state. So this is one way to solve the admission controller's bootstrap. Yeah, and with the Argo Flux thing, we want to support multiple Git repos. Helm v3 has OCI-based registry support as last week. So we already know how to scan container registries. So we have to extend this this feature to and support Helm, like scan the registry and find the Helm chart and update it. And yeah, we want to always improve observability because it's always something you can improve, especially with Flux. That's it. I hope I'm not over time. Any questions?